All right, so today's lesson is how to solve angle addition postulate and angle bisector problems. Now, in our last video, we talked about segment bisectors and segment addition postulate. Angle addition postulate is the exact same thing, only now instead of adding segments, we're going to add some angles. Also, these pictures are a little bit more challenging to draw. So in this problem, it says D is in the interior of angle ABC. So what we're going to do, angle ABC is the large angle. So the first thing that you want to do is draw angle ABC. Now notice that the B is in the center, which means that's the vertex. So that vertex point in our naming angle video, we talked about how angles with the letter in the middle, that's the vertex. So B goes here, and then I'm just going to put A and C by either arrow. So A and C. The next part of the problem says D is in the interior. Now the interior is between the two sides of the angles. So that just means I'm going to put point D somewhere in the interior. Okay? To create our angles, we're just going to connect the ray BD, drawing our picture. Next, we want to put all this information into our picture. So we're going to take it out of our word problem, put it right here on our picture. So the first piece, we have the measure of angle ABC is 122. So little m, that just stands for the word measure. So this is read as the measure of angle ABC equals 122. So angle ABC is here. Okay, notice how that's the big angle. And I'm going to put 122 degrees out in front of the, or out kind of to this side. So that's angle ABC. The next angle is angle ABD, and it's 8x plus 20. So A down to B up to D. This whole section is 8x plus 20. And lastly, we have this angle, angle DBC, and its measure is 22x minus 3. So DBC. And we're just going to fill in that information with 22x minus 3. Our goal of this problem, because remember, we always want to be mindful of the goal. Our goal is to solve for x. So in this problem, once we solve for x, we're done. We don't have to do anything else. First, we're going to set up our general equation, and just like with segment addition, you add the two smaller angles together to equal the large one. So in our problem, it's going to say the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. From here, remember, this is referred to as the general equation. Oh, let's zoom that out. There we go. That's called the general equation. Next, we're going to use substitution. So ABD, we're going to put 8x plus 20 in its place. Okay. Plus DBC, which is 22x minus 3, equals 122. This step is called substitution. Notice all we're doing is replacing. So the name of the angle is angle ABD. We're subbing it in with its actual value. Okay, and then we have DBC. The expression that corresponds to that one was 22x minus 3. And lastly, ABC was 122. From here, all we're going to do is combine those like terms together. So one thing that we've practiced and we've been practicing is when you're combining like terms, just underline them. 8x plus 22x gives us a combined total of 30x. We have the 20 plus a negative 3, or just 20 minus 3, gives us a combined total of 17. And we're just going to bring down that 122. From here, I'm going to move the 17 with subtraction because it's already positive, bringing down the 30x because nothing happened with it, crossing those out. 122 minus 17 gives us an answer of 105. From here, the 30 is being multiplied to x, so we're going to undo multiplication through division. 105 divided by 30 gives us a decimal answer of 3.5. Now in this problem, we don't have to substitute back in and simplify because it already said just solve for x. We did that down here, no substitution needed. In our next problem, let's see, I'm going to add the ray symbol to this question and to this one down here. I can't figure out how to do it on the computer. So on here, it says EF bisects angle DEG. So again, this is the large angle. So you're going to draw angle DEG. The vertex of this angle is E because it's in between the other two letters. So the E goes here, and then I'm going to put D and G by the arrows. Now EF is the bisector, which means the ray starts at E, and F is actually going to be on the line that cuts the angle in half. To show a bisector, you need to mark curves. So on segments we used bars because we use rulers, which are straight, to measure segments, so they get bars. Angles get curves because we use a curved measuring tool called a protractor in order to measure these angles, so they get curves. Okay. So in your picture, EF is the bisector, which means it is cutting this angle into two equal pieces, just like with a midpoint. From here, I'm going to fill in my picture. DEF is 5x minus 3, so DEF, 5x minus 3. And the measure of FEG is 2x plus 15. FEG, 2x plus 15. Now, the goal in this question is to solve for the measure of angle DEG. So when we get our x value, we're not actually finished yet. We have to finish by plugging in x to get our measurement of our angle. Now in this problem, notice how I don't have any information about DEG as a whole, unlike the first example when I knew that the big angle was 122. When you have a problem like this and you don't know any information about the full angle, you're going to just set those two pieces equal because that's all you have to go with. I know that these two angles are the same because EF is a bisector. So we're going to start in our general form. Angle DEF is congruent to angle FEG. Now when we're not talking in terms of equality, we don't use the measurement symbol, the little n. In order to change this from congruent to equals, it's called the definition of congruency, which we talked about in segment addition. So this is the measurement of angle FEG, and this step is called the definition of congruency. Next, we can substitute. So DEF is 5x minus 3 equals 2x plus 15. This step is just substitution. Now we can simplify. So I'm going to subtract the 2x to the other side. And I can't combine them together just by adding them because they're on opposite sides of the equal sign. So these are going to cancel. 5x minus 2x is 3x. Bring down the negative 3 and bring down your positive 15. I'm going to add 3 to both sides to get 3x equals 18. Through division, I'm going to cancel here and get 18 divided by 3 as 6. Now, x is 6, but our goal here is to solve for the measure of angle DEG. Now, in this kind of problem, I need to actually solve and simplify. In order to find the measure of DEG, when the only thing I know is the two smaller pieces, I have to plug x into my expression. So what I'm going to do here, I'm going to get 5 times 6 minus 3, which gives us an angle measure of 27 degrees. When I do it here, I'm going to get 2 times 6 plus 15, which also gives us an angle measure of 27. Now in this problem, if we got two different answers when we substituted, that means we did not do something right over here because these angles have to be equal measures. So if I'm subbing and I notice I get different answers, that's going to be a clue that I need to go back and make sure I substituted correctly or solved the problem the right way. In order to find the value of angle DEG, I have to just add 27 plus 27 to get an angle measure of 54 degrees. So my final answer here, the measure of angle DEG, the measure of DEG is 54 degrees. Just be mindful that you are answering the question that has been asked. Yes, x is 6, but that's not the final answer. The last type of bisector question you can have is a mixed problem. It's kind of a combination between angle addition and understanding the definition of angle bisector. So in this problem, it's the same picture, right? EF bisects angle DEG. So I'm just going to draw the same picture again. Okay. So I'm going to put DEG, point F, and I'm going to mark these two equal. So remember, whenever you see the word bisect, that means that's the ray that's cutting the angle into two equal parts, making these two the same. So let's go ahead and fill in our question. So we've got angle DEF is 3x plus 1, DEF, 3x plus 1, and DEG, that measure is 5x plus 19, DEG, 5x plus 19. So notice in this question, I've given you a part, okay, DEF is here, and I've also given you the whole segment, the measure of DEG being 5x plus 19. That is the big angle. And it's important to recognize that now you have information about the whole angle, which means angle addition is the way to solve this problem. It's different from the second example, because in this one, I didn't give you any expression or number that corresponded to the whole angle. But in this one, I am. Anytime you have the big angle, you want to use angle addition to solve it. Now, it might look like you don't have enough information on your picture, but remember, just like with midpoint, these two have to be equal. So if the only thing I have to go off is that this angle is 3x plus 1, that means this angle also is 3x plus 1. So I'm going to set this problem up using angle addition because I can add my two small angles together. So the measure of angle DEF plus the measure of angle FEG equals the measure of angle DEG. And again, this is called angle addition postulate, AAP, and that's a general equation. Now I'm going to sub. So when we're substituting here, we're going to get the same thing for angle DEF and FEG. So I'm just going to copy 3x plus 1 twice. And together, those angles are going to equal 5x plus 19. This step is called substitution. So right now I've got angle DEF, I know it's 3x plus 1, and I've given you information about DEG, it's 5x plus 19. Notice how in this problem I didn't highlight anything because this problem didn't actually give me that FEG was 3x plus 1. I had to use my context clues and my definitions to know that these two actually are the same. When solving, you're just going to combine those like terms together. So 3x and 3x combines for 6x. 1 and 1 combine for a positive 2. And I'm going to bring down the 5x plus 19 because there's nothing to simplify. Next, I'm going to move the 5x over. I like to keep the variables positive. So 6x minus 5x is just x plus 2 equals 19. Move the 2 through subtraction, and I get x being 17. Now remember, the goal of this problem is to find the measure of angle FEG. So in this problem, the measure of angle FEG is 3 times 17 plus 1, giving me an answer of 52 degrees. So just be mindful that you are answering the question that's being asked. Angle addition is no different from segment addition. The only thing that changes is that you're working with angles and adding them together instead of working with segments and adding those together.